where I am trying to focus to find a different catalyst to speed up these activities. So you can see that in a HER mechanism, how the hydrogen is splitting. You can that, so here you can that one electron is coming and getting involved, and the hydrogen is split in. So for to get out the one one electron will be evolved. So there will be 4 electron will be required to take out the 2 hydrogens. Similarly, for this one, 2 hydrogen, 2 proton are needed to get out the oxygens. So here, hello, can you hear me?
Sir, yes, sir. Help, sir.
Okay, thank you.
Yes, sir.
For confirmation. So here,
yes,
like,
sir.
So what I am trying to show here is that this is a material where I'm trying to find out, you can call it as a catalyst. On that, this HER and OER we are performing. These catalysts will be coated on this anode or a cathode to fasten these reactions. So we try to find out a material which do this catalyst activity very fast. To understand this one, we need to understand the HER as well as OER reaction. See here, like I try to do this HER understanding on a graphene case. This is a graphene layer. Hello. My screen is visible or it gone?
Sir, it is very much visible, sir.
Visible, right?
It is visible, sir. Yes, sir.
Okay. So you can see that this is a graphene sheet. So you can see that we try to do HER and OER on this material, and so like what I see that first when the one hydrogen will come and sit on this graphene sheet, and we understand its free energy by doing the DFT calculations, and another hydrogen will come during the absorption. So when these 2 hydrogens come near, then they evolve as a H2. This is a simple way of showing the hydrogen evolution reaction. Similarly, to understand the oxygen evolution reaction, you can see here, you can visualize it. Here is another step. I will come to here this one. First we, like here, this is a catalyst. And this first on this catalyst, the OH will come and attach. We can start from here. This is a bare catalyst. There is no absorption of OH or anything. So during the reaction, the OH will come and sit on this catalyst. This catalyst may be any material that we are trying to find. But here I'm only showing some of the reaction mechanism before going to our analysis. So like this OH and coming and attaching. And the next step, another OH will come. And from this OH, it will bind to the hydrogen available here, and the H2 will be evolved. So then we left with the one oxygen. So then again, then another OH will come. So here we end up with the 2O and H. So this O is evolved again. So then this we can come up with the oxygen evolution. So we get the 2 oxygens here. So that in this way we can get the oxygen evolution. In the previous step we got the hydrogen. Here we got the oxygen steps. So in order to do this calculation, we solve the Gibbs free energy. From that, we try to understand the over potential. What is that over potential? And from that, if we have a lesser over potential, that material is good for our application for the HER or OER. With this background, I will go to our study. Here we studied on ruthenium core cell. This is our study where we it's a quantum a core. Like you can consider it as a quantum dot. So it is made of ruthenium. So you can see here. So here we try to understand its OER mechanism, whether it is good for our or how we can improve its OER facility. So usually the ruthenium core is not good for the what we understand from our real studies. The ruthenium is good, not good. So we doped with the nickel. So that here you can see the nickel we doped, and we found that with the doping of nickel, then we can achieve a high means lesser over potential with the high catalytic activity for the oxygen evolution reaction. So you can see that there are two in oxygen evolution also there are different types of oxygen evolution happens. So one is that it comes and it takes the oxygen from the alkaline solution only. But there is another that is usually called absorption evolution reaction. Another possibility is that the another oxygen comes out of the lattice. Means in the RuO2, there are different oxygen atoms in the crystal structure of that catalyst. So that oxygen is also coming from the this catalyst. So that type of oxygen evolution is called the lattice oxygen evolution that we represent as by the LOM reactions. We found that this is the first time we observed this type of mechanism. So that's what it published in Advanced Energy Material in 2021. And we found that this is the main reason for this nickel doped ruthenium giving a better catalyst for the oxygen evolution reaction. So we applied this approach to a Maxine, where we already previously shown that Maxine is gaining much attention. This is a two-dimensional machine, Maxines. So we modeled different type of Maxines, like a three layered Maxines with a different combination of the metals, like a scandium transition. So we combined all these type of Maxines, and we end up with around 400 combinations of the Maxines. We consider these of all the 400 Maxines, and then we try to understand the lattice oxygen mechanism. Means whether these Maxines are good for oxygen means OER mechanism or not. So which in those 400 also which are better, and how we can whether which are not good, whether we can improve their catalytic activity by different approach. We try to find out that in this study. So here, like you can see that as I shown, this is a similar kind of transition metal. Like for example, if I consider this as a M, this blue color one, if I consider scandium, all these metals are scandium. In another case, this is scandium. In the middle layer, I am putting like a tellurium, like a titanium or a vanadium or chromium. So like that, we are making a different configurations around 400. In that one, we try to understand the HER as well as OER in this material. So this is a how we are doing our approach. This is the crystal structure of that Maxine. Okay, you can see that these Maxine are terminated with the oxygens as well. And here this is a metal, and this is again a carbon, metal, carbon, and the transition metal. Maybe it is scandium or yttrium or maybe another things. Or again another termination is oxygen. So like again, I told in the beginning that we are following these steps. Initially, the one oxygen is that OH is coming and sitting on these metal surface, and then this follows, and we finally get the oxygen. So we understand, do the different density functional theory and get the free energies. That is called Gibbs free energy. That will give a final over potential. And we tried different mechanism. That there are two different mechanisms are there for the oxygen evolution mechanism. So and this is the Gibbs free energy plot for different materials. Like we had told, right, different configurations of maxims we have made, and from there we try to get the Gibbs free energy for both oxygen evolution reaction as well for the hydrogen evolution reaction. So here to be the material should be a good for HER, their Gibbs free energy should be near to the zero. So we can see that there are different combinations of maxims are here we plotted, and here we shown a Gibbs free energy which are near to the zero. They are good for our HER. And you can also see here like which are, this is a heat map. Instead we cannot understand here, we shown a heat map which are lying with yellow in color. They are good for our HER evolution. For example, the titanium with a combination of other metals are good for our HER, and similarly with these combinations. So with these studies, we have found few maxims are good for our HER property, and then we try to find this one for the HER applications also. And also like we found that we again like applied these same method to obtain the nitrogen fixation. Means here we try to um, remove the from the methane we remove the uh, nitrogen, or maybe like vice versa. From nitrogen we try to get the methane. So you can see that for to do these things, what type of two-dimensional materials are good, we tried in that way, and we focused another type of 2D materials, that is already told, TMD, transition metal chalcogenides, and there is another two-dimensional material called M-beans. You may be these materials maybe you may be hearing for the first time, but if you go and find and dig about the M-beans, they are really another class of good two-dimensional materials which really give better um, transition metal properties. So here again, like the same method I already told. So here the to understand nitrogen fixation, we need to follow different lengthy step. Whereas for the HER and OER, HER is only single step. OER is a 4-step method, but for the nitrogen reduction means to get the ammonia, we need to follow like around 1, 2, 3, 4, 5, 6, 7, 8, around 8 steps. It's really a long step calculation. So initially we absorb the nitrogen and then get N2H, and then another H will come. So like that we need to follow all these steps, and then in the end we get the ammonia, that NH3. So we for like that we done for a different two-dimensional material, that is transition material. If you consider HI to see here, like we only shown a good one. There are like several other things which we tried, which didn't show a good results. We didn't show here. So these are the in the pink color, whatever the you can see, right? These are the good two-dimensional material which we can uh, do for the good for the NRR applications. So these are the different approaches what we have earlier approached. So now, like I just wanted to show that I have almost all and come to my end of my presentation. So here, like I just wanted to show that I also worked with this Yuri Gogotsi, who is um, a main guy for these vaccines. You can see that uh, this is Yuri Gogotsi, and where we try to find out different ligands that can be synthesized easily. And another one which I work for the optical properties, that is using the photovoltaic devices, again with Yuri Gogotsi. So this is a few brief discussion about the vaccines. So I will thank my end my presentation. If you have any things to ask, you can go ahead, or you don't. If you don't have understanding anything, I will go back and explain again. Please ask whatever the things you have.
Thank you, Arun sir. Indeed,
Yeah.
those who are in the field of theoretical sciences, for them this is a completely boost, I must say. Sir, I do have few questions.
Okay.
Sir, in the past, most of the theoretical calculations used to happen via Boltzmann transport equations. We
Yes.
used to
Yes.
derive varieties of equations, and then using softwares like Python, now earlier C language, and there were many mathematical tools.
Yes.
But
Yes.
nowadays, most of the papers that I am seeing are not on Boltzmann transport equation, but on DFT and similar. Question is,
I
are
will.
they still relevant, sir?
Yes. Yes. I will tell you, sir. Once I repeat. So these DFT calculations. I can you see my slide here? Phonon dispersion
Yeah,
and thermal
yes, sir.
conductivity.
I can see. I can see, sir.
Okay. Here the to get the phonons means that are the means give the frequencies. Okay. To get the frequencies for the to calculate the lattice thermal conductivity, we are using density functional theory. Okay. We are not using the DFT to get the thermal conductivity.
Hmm.
Still the thermal conductivity, final lattice thermal conductivity or electrical conductivity is done by the Boltzmann transport equation only. But earlier what we are doing, like we are to solve the Boltzmann transport equation, we need to have some frequency or energy calculation that we are getting from an empirical formula. Like for example,
Yes,
E equal to H nu, something like that, or some wave function. But
yes.
those have some approximation, but we are getting those frequencies by DFT methodology, where it will give a full uh, wave picture. Means completely phonon band structure, or a completely phonon electronic band structure. Using
Very
that
good.
one, we again use another code which is mainly contains the Boltzmann transport equation, which uses the DFT input, which uses
Hmm.
the DFT as an input. So that's what there is a confusion here. DFT will not give exactly the um, thermal conductivity. It just gives some input for the to calculate the thermal conductivity, even for the electronic conductivity also. Still, we
Sir,
are using the Boltzmann transport equation for the calculating thermal conductivity as well as electronic conductivity.
so even today it is very much relevant, sir. We have to rely on that only.
Yeah, yeah, yeah.
Yeah. Okay.
Yes,
Um,
that's what like these Boltzmann transport equation are already another code. We call it as a people are calling it with a different name. My previous guide has developed it's like my postdoc guide. It's called Sheng BTE because he's a Chinese. He named it as Sheng. Sheng means sound, and the BTE again, Boltzmann
yes,
transport equation. So it uses the DFT inputs. Yeah.
great, sir.
So anybody
Dear
has any basic question also, I'm
participants,
happy to answer.
do you have any other questions, dear participants? You can post it in the chat box,
Or you
or
can
you can
ask
directly.
directly also.
Yes, yes, that will be still better. Sir, can we bypass BTE and using only DFT, can we calculate all the parameters of any material, say, for example, thermal conductivity or maybe thermopower? Can we use DFT for that?
Can you repeat? Can you repeat?
Sir, can we bypass the Boltzmann transport equation and use only DFT related techniques to modulate the experimentally observed data?
Yeah. Like for example, for example, if you want to understand the band gap of
Yes.
any material, you can directly use the DFT only. And if
Okay.
you wanted to understand some optical properties like absorption spectra or this thing, that can also be directly done by the DFT codes only. So like that, you can like for example, it will usually DFT will give some eigenvalue. You need to do some post scripts so to get the
Okay.
desired properties.
Okay. Got it, sir. Thank you so much.
So anybody has any questions?
Anybody,
Or
dear participants?
it means that what you guys didn't understand what I show.
No, no, no. The thing is, they may be experimentalist or maybe people from E and C and CS background
Okay.
because it is pan-India FTP, sir. And
Okay.
people from anywhere from India they can attend, and we are fortunate that there are many from outside Karnataka, sir.
Okay. Okay.
Okay, and that's really great, sir. So
Yeah.
that this knowledge is also very important. Like most of the speakers in our FDP, they have mentioned DFT techniques, sir, without doubt.
Oh, okay.
They have mentioned DFT and the related techniques.
Oh,
Yes, sir. So, dear participants,
if you have
I
any question,
want to
just
give,
type also.
yes, yes, they can type, sir. So, dear participants, I have some information to give you, and it is related to the test which will be hosted on the ATAL portal. It is the same, website on which you have registered for this ATAL FDP. Use your credential, log in to your ATAL portal as participant, and once you do that, you will find assessment link there on the give the assessment. There are 30 questions and very simple. You answer them and then go to feedback section, give your feedback. And for this process to take place, it is from 6:30 to 7:30. And exactly at 7:30 or as and when you complete, you join this meeting again. We will be here always till 8 o'clock. We will be here, and from 7:30 to 8 we will have our valedictory session, and I request you all to be present here because we expect that some of you give feedback online because that is very essential. I hope you will definitely do that. So, dear participants, you can do that. And now, Arun sir,
Yeah. Yes, sir.
please switch on your videos.
Hello.
Sir,
Can you hear me?
sir, you can stop sharing now. Yes, sir. Yes, sir. Thank you so much, Arun sir. I am not seeing your video now.
Yeah. Now I think.
Yeah, 1 second, sir. Arun sir, are you there?
Yeah.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. Sir, on behalf of all the participants, I would like to thank you, sir.
Thank you for this opportunity.
This was a very wonderful session. And on behalf of KLS Management, on behalf of our beloved principal, Dr. V.A. Kulkarni, sir, and also from organizing committee, I uh, my heartfelt gratitude to you, sir, because when we approached you with this, you without any hesitation, you said yes, and uh, definitely your talk was very stimulating, and I hope your support and cooperation will be with us in the future also whenever we host such um,
Yeah.
meetings. And definitely, sir, whenever you are in Dharwad, please give us a call so that we can also use your expertise for our students also.
Yeah, sure, sure.
Yes,
That
sir. Yes,
I'm even sorry, even I'm also not able to go to my home tour also because of some
sir.
uh, you may be knowing that our work because of some work
Yeah,
schedule.
yeah, definitely, sir. Yes, sir. I can
I will
understand.
definitely I will come and
Please, sir. Please, sir. Uh, yeah. So, dear participants, thank you very much. Now, you can also log into your ATAL portal by being here in the meeting itself. I hope you can do that. So, 1 hour, you can take a break, answer assessment, and then feedback. Arun, sir. Uh,
yeah.
yes, sir. We'll see you, sir, later, sir. And thank you very much, sir. Thank you. I repeat once again, dear participants, please log into Atal portal, complete test, and give your feedback and come and join this meeting once again. So maybe we can prepone our valedictory also. Thank you so much.
Good evening, sir.
Gurraj sir,
Galgal, sir. I am
please.
audible, right?
Yes, sir. Video, sir. Audible, sir. Very much audible.
Well,
Video, sir. Video. Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Thank you. So it is 7:30, sir. Now let me start valedictory function. I hope it is okay to all of you. Um, I wholeheartedly welcome you all for this valedictory function. As you all know, it's been 6 days. We are into this very rigorous process of teaching and learning program. Dear participants, being on screen for more than 3 hours is very, very challenging. And I can understand the process through which we all have been. And I congratulate each one of you for engaging yourself in a very, very productive time. And as you all noticed, all the speakers were extremely expert, having expertise in their own field. And we are fortunate to get experts from outside India working in reputed institutions and research center from outside. Especially, I would like to mention Dr. Shivasav Surbhi and Dr. DP Singh. And the last session was from Dr. Arun Nisim Gaudar. He too is working in the area of lithium-ion batteries at Ola company. So likewise, we have managed to get people from industry, people from research centers, and academics also. So I hope our effort in bringing all these expertise have really benefited you. And as I mentioned, your participation has much more meaning, and I hope you have made better use of all these things. And now it is the time to open up this particular platform for feedback purpose. I request, if you are some of you should voluntarily switch on your videos and mic and express few words about this particular FDP. And sorry to mention, I wholeheartedly welcome Dean Academic Dr. Gururaj Hatti sir, Dean Academic of our institution, KLSVDIT, for this very event, uh, valedictory event. Please, sir, I welcome you, sir.
yeah, thank you. Thank you, sir.
Yes, sir. Now the session is open for the feedback. Uh, Anybody would like to come first, please?
Hello, sir.
Yes, madam.
Yes, sir. I would like to give feedback about the FDP.
Please go ahead, madam.
Good evening to all. Respected Principal, Dr. B.A. Kulkarni sir, Dean Academic, Dr. Gurraj Hatti sir, uh, organizers of this FDP, Dr. Galgali sir, Dr. Sannaikar sir, and the entire team. Uh, myself, Dr. Meenal Khaliwal from ENC department, KLSVDIT Haliyal. This faculty development program on nano semiconductors organized by the Basic Science and Humanities Department was highly informative and well structured. Even though I'm from the mathematics background, but still the sessions from Dr. Arun sir and Dr. Surbhi and Dr. Singh, it gave us a clear idea about the advanced concepts, recent research trends, and practical applications in nanotechnology. These resource person delivered the content very effectively, making complex topics easy to understand. So overall, it was a well-organized FDP that enriched the participants' knowledge and encouraged further exploration in the field. So thanks to all the organizers. Thank you, sir.
Thank you, madam. Thank you so much. Can I take few names here who were usually present? I saw them. Prabhakaran sir, are you there? Please. Please unmute yourself, sir. Bhavik Harshad Kumar, sir.
Good evening, sir.
Good evening, ma'am. Please go ahead.
Sir, myself, Dr. Sneha S. Kulkarni from Department of Chemistry. So,
Yes, ma'am.
the FDP was meticulously organized, ensuring the clarity, engagement, and seamless coordination throughout. I thank our beloved principal, Dr. V.A. Kulkarni, sir, the organizing committee. Thank you, thank you.
Thank you, madam. Thank you.
Good evening, sir.
Yes, sir.
Sir, this is Dr. Chandru from the National Institute of Engineering, Mysuru.
Yes,
Hello,
sir.
sir. Can you
Go
hear
ahead,
me?
sir. Yes, sir. Please switch on your video, sir. Can you switch on your video, sir?
Yes.
Yes,
Hello,
sir.
sir. Can you hear me?
Yes, sir. We are hearing you, sir. Definitely.
Yeah, sir. Actually, sir, all the sessions are very informative and all the speakers are presented very well. Thank you so
Yes.
much for organizing such a wonderful faculty development program, sir. Thank you.
Thank you very much, sir. Thank you.
Thank you.
Thank you.
Dr. Sangeeta Benny here, sir.
Yes,
Am I
madam.
audible?
Yes, madam. You are audible.
Firstly, I would like to congratulate you all, sir, for having successful ATAL FDP completion.
Thank you, madam. Thank you.
And the sessions were really very much informative. And all the sessions, some sessions have given me more, what do you say? I can take my research to next levels. I have received so many ideas from all these sessions. So thank you very much.
Thank you, madam. Thanks a lot. Thank you. Pushpalata, madam, is here. Dr. Krupa P. So, dear participants, when you were all writing tests and giving feedback, we have also received some queries regarding certificates not getting downloaded. Don't worry. I inquired about it from one of my friend who has already organized two FDPs in the recent past. On inquiring, he said certificates will be downloaded. It will take its own time. Maybe by after 8 o'clock, you will receive your certificates. Definitely, it is with them now. You have attended the test. You have submitted the feedback. Then don't worry at all. Uh, your certificates will definitely be get ready, and they will take their own time. So no need to worry much. If some of you would like to give feedback, please open up yourself, because uh, your feedback will definitely help us, motivate us to organize more and more like these events in the near future. And as I said, hats off to your patience for all these days. It was indeed very encouraging to all of us. Thank you so much, dear participants. So, sir, uh, Gurraj sir,
Yes, sir.
sir, shall we proceed further? Because I guess,
Yes, sir. Yes,
okay.
sir. As and
To
when somebody wants to give the feedback, they can
yes, sir.
give. Yeah,
Yes,
especially apart from Karnataka, outside Karnataka, if any
yes,
participant want to give,
yes.
we can proceed to the next session, sir.
Rajesh Singh sir is here. Kya? Sir, we will go ahead with the next process.
Yes, sir.
Uh,
Yes, sir.
Dear participants, this function was very much supported by all our teammates, and we have, because our principal sir is busy with some other meetings, I requested Dean Academic to be present during this valedictory function, and he is here with us. I request our Gurraj Hatti sir to make presidential remarks, please.
Uh, First of all, I would like to congratulate the both the coordinates with respect to the this ATAL FDP, Dr. Samir Galgali sir as well as Dr. Sarnaikar sir for successfully completing the ATAL FDP, which is the first FDP. I think the institution has been organized successfully, and I want to congratulate the whole team, the Basic Science and Humanity, for supporting both the coordinators, and I hope they are the uh, will be the guide for the next departments who will be applying and who will be conducting this kind of FDPs, especially with respect to ACT, ATAL, as well as the other science and technology bodies. And one more thing I want to convey with respect to all the participants who are attending these valedictory functions, who are attending from all over India. So our college, especially the KLS Vishwanath Rao Deshpande Institute of Technology, Haliyal, has been located in the Western Ghats, which is very much uh, near to from Dharwad and Hubli, because the people are very much familiar with these two places, especially, and they are very near. And please do visit our institution whenever you people are visiting the places like the Hubli as well as Dharwad, right? As well as we have certain facilities for research purpose in the Department of Physics, in the Department of Chemistry, as well as in the Department of Engineering branches. And also, the college has been growing with the in the part of education, in the part of research, as well as uh, curricular and co-curricular and as well as the extracurricular activities. So in this regard, I would like to thank our KLS management, our principal sir, for guiding and supporting to conduct all such activities, as well as all the teaching and non-teaching faculty members who are involved in conducting such activities. So I once again congratulate the whole team for successfully completing this adult FTP. Thank you, sir.
Thank you very much, sir. Thank you very much. And to make concluding remarks, I too want to thank our KLS management for their uh, kind support, and especially I want to thank our beloved principal, Dr. V.A. Kulkarni sir, without whom this ATAL function could not have been possible. From day one, from the date of applying till today, he is asking about the progress and all, and he still wanted to join, but because of some other meetings, he could not. And I thank our principal, Dr. V.A. Kulkarni sir, for his kind support and guidance. And I thank all my teammates and especially you all, sir, Dean Academic, Dean Research, and Dean Triple I, and all my teammates here from Basic Science and Humanities Department for their kind support and cooperation. And here is the closing day, sir, today. And I hope for most of you, these 6 days you will be waiting till 9 o'clock for the completion of this event. So today, since it is last day, we are almost nearing the end. And on behalf of all the organizing committee, on behalf of KLSVDIT, I congratulate all the participants for their active engagement throughout these 6 days. And yes, thank you one and all. Thank you very much. Here we conclude our valedictory session. And I hope in our next endeavors also you will join again with the same enthusiasm and spirit. Thank you one and all. Thank you everybody.
Thanks.
Thank you. Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you. Thank you. Thank you.
Thank you so much, sir.
Thank you, sir.